Okay, today's video is dedicated to Haley Harms, who has a very, very badly hurt ankle. Haley, I'm an expert on injured ankles, and so you can come talk to Mr. Gens. I'm an expert on everything. I would encourage you to ice and rest, and as soon as you can, start walking on the darn thing, okay? Because that's how you get rid of some of the swelling and hopefully be better. So 24 hours of rest, then try to start walking. Don't run like figure eights. That would be a bad thing, but straightforward walking, always a good thing. Yep, she will. She will. All right, so let's do it. Vectors and dot product. Last lesson before the test on Friday. Tomorrow you have a full day to work on your study guide, which I gave to you yesterday, and Gabe is not here. Where's Gabe? Historical Museum. Got it. We don't know. Yes, Emily, best ever. And we're going to get to that in a little bit. Thank you for pointing it out. All right, dot product. If U is equal to the vector A1, B1, and V is equal to the vector A2, B2, then U times V. The question is, how do we multiply two vectors together? Well, we showed you how we add two vectors together or subtract them. You simply add or subtract the horizontal components and add or subtract the vertical components. If you're going to multiply them, what you do is you take A1 times A2. That was a very bad A, sorry. A2 plus B1 times B2. Got it? What do you think? Yeah? You're hearing noises? Yeah? Yeah, so, yep, it's the door handle. It's like the, like going, door handle starts making sound. Touch it, stops. Yep. You always think to start a stupid class. You want me to open a crack? Right, hopefully that'll stop. Okay, yes. Wherever you want. You get a sheet of paper. So it says find the product of the vectors and the angle between them. The product of vectors is generally referred to as the dot product. And so we will multiply them together. Very simple. All we do is we take -1 times what? 2 plus 2 times 3. And we get -2 plus 6 is 4. That is the dot product. So you don't get a horizontal component, vertical component, rather you just get a number. Or this is like 1, -1, and then B is 3, 4. Okay, so this is in terms of I and J. We multiply them together. What do you get? 3 plus -4, which is -1. What do you think of that? Easy peasy, lemon squeezy. So if I ask that on the test, you're going to be like, yay, thank you, Mr. Gens, for problems I know I can get correct to boost my grade. You're welcome. Okay, let's give you more problems that will boost your grade. Ready? Grade booster problems. Cosine of theta is equal to U times V, or the dot product, divided by the magnitude of U times the magnitude of V. I could prove it for you. I will not. But that is how we find the angle formed between two vectors. We would say the magnitude of the vector would really be the absolute value, the distance it is from the origin. I don't know what you're asking. No, I'll show you. Okay, so as you look here, U is -1, +2. All right, so that's a vector. And then you have 2, 3. So over 2 and up 3. That's another vector. The question is, what is the angle formed between those two vectors? It says find the product of the vectors and the angle between them. We use this formula. It's very simple to set up. We say the cosine of theta is equal to U times V. We've already done U times V, haven't we? What is u times v? 4 divided by, this means, so this gets to our question that Hannah asked, the magnitude of u. Magnitude of u is square root of a squared plus b squared, correct? What's a squared? 1, b squared. 4, added together, square root, root of 5. Oh, magnitude of v, a squared, 4, b squared, 9, added together, 13. So you get 4 over the root of 65. On your calculator, we're trying to solve for theta, so you got to do cosine inverse. Take it out. Cosine inverse, make sure you're working in degrees or radians. Which one? Degrees. Vectors, we work in degrees. Complex numbers, we work in radians. Yes, you have to switch back and forth. Make a note. Write it down. Degrees. Do cosine inverse of 4 over root of 65. What do you get? Ooh, got a bunch of lazy people without calculators out. Cosine inverse of 4 over 65. 60.26. Thank you. Theta is 60.26 degrees. Cosine inverse. Yes. Okay, so that's what I have. 60.26 degrees. Now, I have a question for you. Is this acute or obtuse? It's acute. How would cosine know if it was obtuse? It would be a negative value, right? Is cosine positive or negative in the second quadrant? It's negative. And the second quadrant is where we got angles from 90 to 180, so obtuse. So if it was negative, you come up with an obtuse angle. Just see if you can do the second one, okay? Find the angle for the second one. Go, go. It's a race. Garrett's winning. And Haley says she's done. Nice job, Haley. Haley, if you're watching the video, you can press pause at any time and go and get yourself a snack. If I were you, I would have some peanut butter chocolate ice cream. Canadian bacon pizza. Oh, I love Canadian bacon pizza. Or Haley, I would make a list of all the reasons why you would not go to Iowa University. She can go to Wartburg. Great mathematics department. She should major in mathematics. Be like a Mr. Gantz someday. All right, what do you got? We got cosine of theta is equal to -1 over. I got the root of 2 times just 5, right? Okay. So -1 over 5 roots of 2. What do you get when you inverse that? 106.42. Whatever. 106.4243 degrees, whatever. There you go. You're able to inverse and find that. All right? Can you find a dot product? Can you find an angle between two vectors? Good. So there's some easy points for you on the test. Dot product, yes. Orthogonal. Teach you new words. Say orthogonal. Go. Orthogonal means perpendicular. All right. Work with me here, folks. Cosine of 90 degrees is what? 0. So if the angle was 90 degrees and it was perpendicular, then the cosine would be equal to 0. Well, tell me, if we look back at our formula, cosine of theta equals u times v over magnitude of u times magnitude of v, would that mean that the top is 0 or the bottom is 0? The top is 0. So all we have to do is this. Orthogonal vectors, if you take u times v and you get 0, they are perpendicular. Orthogonal. Perpendicular is a phrase used for line segments and lines. orthogonal is reserved for vectors? I have no idea. I'll research it. Go to Wikipedia. It's an online dictionary. Okay. Actually, encyclopedia. Determine whether the following vectors are orthogonal. Well, all I have to do is do the dot product. And if I come up with 0, then they are orthogonal. So, 2, 1 times negative 1, 2 is 2 times negative 1. Yes, thank you. Plus 1 times 2, 2, and I get 0. Are they orthogonal? Yes. Next one, I got 5, negative 3 times negative 6, 10. 5 times negative 6. Negative 30 plus. Negative 30 is negative 60. Oh, not 0. Are they orthogonal? No. Sad day. Let's not do components of U ln V. Yes, if you see components of U ln V in your study guide, get rid of it. Hey, let's look at example 3. Find the component of U ln V. Oh, let's get rid of it. Let's save 4 in case we have extra time tomorrow. Let's look at calculating projections. Okay, done. I actually never teach any of this. I just put it on there so we could cross it off. And then you guys are like, oh, wow, he's a really nice guy. Like, I've never actually taught any of it. I just okay, what can we add to cross off? They'll be so much happier. Okay, Haley, here we go. Work is equal to force times distance. Force times distance. For example, if I am bench pressing, I am moving, I'm exerting force, say 100 pounds of force, and I'm moving it, say, 2.5 feet. Okay? So there's a certain amount of work that I'm doing. All right? Let's look at the abstract example, and then we'll look at a real life example. Suppose we want to find the work done by a force F. So the force is right here, and we're moving the object from P to Q. So we have to write a vector for the force. Anybody know what the vector for the force is? 1, 1. Because force is I plus J, and so that vector is 1, 1. Got it? Then I need a vector that represents the distance that it has traveled. If it goes from 0 to 3, how many horizontal units has it traveled? 3. If it goes from 0 to 4, how many vertical units? 4. So I am asked to multiply these two vectors, and it will then give me the amount of work that has been done. So this is a dot product, 1 times 3 plus 1 times 4. So 7 units of work have been done in this example. 7 units of work. See if you can do the next one on your own. Go. Yes, the answer is 7. I'll box it for you. Boom. -1 is the correct answer. Are there any questions how I came up with -1? What up, dog? This one. You take, what is the distance to get from 0 to -1? You traveled -1 units. You take -1 minus 0. Distance to get from 3 to 2, -1. You did 2 minus 3 to get -1. You got to take the latter minus the former. Okay? See that? X sub 2 minus X sub 1. Y sub 2 minus Y sub 1. Okay, let's apply to real life problem. One more! This is the old-fashioned. I probably need to mow my lawn tonight. So my grass clippings flying everywhere because I'm pushing the lawnmower so fast. EJ, what do you think? Thank you. The lawnmower is being pushed a distance of 80 feet. The handle at a constant force of 60 pounds. The handle is at a 35-degree angle to the ground. Find the work being done. Work is equal to force times distance. I need a vector for force, and I need a vector for distance. Distance 1 is easy. Vectors have horizontal and vertical components. What is the horizontal component of the vector if it's being moved 80 feet? 80. What is the vertical component? 0. Similar problems in your study guide. We have not done this exact problem. Force. Well, force is different. I have the magnitude of the vector is equal to 60, and it has a vertical component B and a horizontal component A, and it makes a 35-degree angle with the ground. So the horizontal component, how do I calculate that? Oh, wise ones of the mathematics world. $60 times the cosine of 35. Very good. How do you calculate the vertical component? Very good. So we did that the other day, right? We calculated horizontal and vertical components. Magnitude of the vector times the sine or cosine of the included angle. So what is 60 times cosine of 35? 49.14. Thank you. And 60 times the sine of 35. Go. Very good. So I have force. I have a vector in component form for force, and I have a vector in component form for distance. So the formula says take work is equal to force times distance. So I know how to multiply two vectors. Easy. Use dot product. Work equals force 49.14, 34.41 times 80, 0. I love it when there's no vertical component because anything times 0 is 0. That was easy. So I have 49.14 times 80, which is what? Plus 0 is 3,913.2. Let's think about our measurements here. What is force measured in? Pounds. What's distance measured in? Feet. So we have foot pounds. Foot pounds of force, not foot over pounds, not pounds over feet. Torque would be foot pounds squared. See that? Not too bad, huh? All right. One more example, and then we are done. Please go back to this one. Whoa, pilot problem. And your assignment today is rather short. I know how stressed out you are. Y'all got a tough life. I help try to make it easier. Pilots headed due west. Due west. Got that? How's going west? What's the speed of the pilot right now? 450. Straight west. So we're going to write 450 is the magnitude of the vector. That is straight west. Okay? The wind is blowing north 20 degrees west at a speed of 60 miles an hour. So 60 will be the magnitude of the wind vector. So I won't draw it as long. So that's 60. And it makes a 20-degree angle with the north side, right? 20 degrees to the north. So how much does that leave left over right here? 70 degrees. Okay. So think about it. Plane's flying. It's hitting a wind. Is this wind affecting the travel of the plane, do you think? Yes. Is it affecting the travel of the plane more towards the north or more towards the west? Towards the north, because the majority of the wind is blowing towards the north, right? Just a little bit to the west. Okay? So it's going to knock it off course a little bit, right? Furthermore, it's going to affect its overall speed. All right? So we want to actually try to understand the true speed that this plane is traveling in the direction. It says express the velocity of the wind as a vector in component form. So what I have here is this wind, and I want to express this as a vector in component form, where this is B and this is A. Well, I know that the horizontal component, A, is equal to what? 60, which is the magnitude times the cosine of 70, and B is 60 times the sine of 70. Good. Let's calculate those both real quick and put them in component form. What do you got? $20.52. Good, and you guys told me that there was a stronger vertical component than there was a horizontal component, correct? And it shows up right there. Second question we really got to think about a lot. So, Haley, pay attention. Express the velocity of the jet relative to the air as a vector in component form. Ooh, this word right here, relative. Got to think about it. It's not like who's related to who, but something else, okay? So, Annika is at the airport, and I'm at the airport. And she's sitting in the seats waiting for Lindsay to come flying home from nationals. I don't know. So, okay, great. All right. You ever been to the airport? You haven't. At the airport, they have these escalators that don't go up and down, but they're just like moving sidewalks that take you quickly, right? So, suppose I'm walking on the ground, not on the moving sidewalk. I'm walking at a speed of 3 miles an hour, and I see Annika, and I wait. Relative to Annika, how quickly am I moving? 3 miles an hour. Back up in time. I am going to my destination. I'm going to Australia. Okay, that's where I'm headed. And I step on the moving sidewalk, which is traveling at 5 miles an hour. And I'm standing on it. And I go whizzing by, and I see Annika. Hi, Annika. How fast am I moving? I'll send them to the office. Anna, anything to say?
We miss you.
Oh, Megan, anything to say? Hey, Haley. Sprain your ankle. I don't know, but maybe you should send her a get well card and make some brownies for her. You ever think about that?